Hello everyone, I'm Paul and today we're solving problem 2071, maximum number of tasks you can assign. So this is a hard problem, but I think it's very interesting because it can be useful to understand binary search in depth, because here we are using two binary searches. So keep watching for the intuition, the approach, and the solution. For this one, we are given an array of tasks, another array of workers. We are also given pills and a strength. And we need to return the maximum number of tasks that can be completed. So each worker has a strength, and each worker can solve one task only. Also, each worker can only take one pill, and each pill has this strength. Let's see what this means with an example. Let's say these are the tasks, these are the workers, we have one pill and strength is 5. So we could give one pill to any of these workers. Let's say we give this pill to the first worker. So this worker has now a strength of 5 and we have 0 pills. And now, with a strength of 5, we can solve the first task, and this worker won't be able to solve any more tasks. So these two workers won't be able to solve this one, because now we don't have any pills. So our result is 1. Now let's see how can we solve this with another example. Now let's say these are the tasks, these are the workers, we have one pill and strength of 5. The first step will be to sort. So this array is now this, and this array is now this. And next we will do a binary search on this array of tasks. So let's suppose left pointer is here, right is here, and mid pointer is here. So we are checking if with these workers we can solve these first 3 tasks. Okay, we are checking if we can solve every task from 0 up to the midpoint with our workers. And to check this, we need to iterate our tasks from the midpoint up to 0. So starting from 8, we are checking if our stronger worker, which is 6, is greater or equal to 8. And in this case, it isn't. So we could give our pill to this worker, and this worker would be able to solve this task. But maybe that's not smart. Maybe we need to give our pill to some other worker, and that is more intelligent. Why? Because if we give a pill to this worker will have a strength of 11. And remember, we need to solve a task of 8. So here the difference between 11 and 8 is 3. But maybe it could be more intelligent to give this pill to some other worker, such as this one. Because let's see what happens. If we give a pill to this worker, this will have a strength of 4 plus 5, 9. And 9 minus 8 is 1. So the difference for this worker is 1, and 1 is smaller than the difference for this worker, which is 3. So our best choice in this example is to give our pill to this worker instead of this one. So by doing this, now this worker is used, we have no more pills, and we can solve this task. And next we need to solve these 2 tasks with our remaining workers. So we can use, for example, this worker for this task and this worker for this task, and that's it. We know that we can solve 3 tasks in this problem. Now let's get back to this. First we need to solve a task of 8 and we have these workers. So we need to find the perfect candidate for our bill, because we don't have any worker that's bigger than our current task. So we need to give this bill to someone to solve the task. The question is, who is the perfect candidate? And the most efficient way to find a perfect candidate here is to do another binary search. So we are checking in this array of workers which one can solve the current task and also have the lowest difference. Now remember that the strength of the current worker plus the strength of the bill should be greater or equal to the task. So to find the worker, we can do task minus strength. And if we do a binary search with this formula in this array, we can find the perfect worker for the current task. So right now, task minus strength is 8 minus 5. So 8 minus 5 equals 3. So we are doing a binary search here with these 3. So left pointer is here, right pointer is here, and mid pointer is here. So in this case the mid element is 4 and 4 is greater than 3. So we update the right pointer to the mid pointer. Now right is here, mid is here, and left is here. Now we are checking if 2 equals our difference, and it is smaller than our difference, so we update the left pointer to mid plus 1. Now left, right, and mid are here at 4, and left equals right, so we return left, which is index 2. So we know that this is the perfect candidate for our bill, and we use this worker to solve this task. Next, we are checking if any of our remaining workers can solve this task. So we are starting from the stronger worker, which is 6, and 6 is greater than 5. So this worker can solve this task. And similarly, this worker can solve this task. So our result is currently 3 tasks. And next, left is here, right is here, and mid is here. So we need to solve this task with this new array of workers. Now we can find who should be the perfect worker for this task by doing 9 minus 5. This is equal to 4. And next we do a binary search with these 4 in our workers array. So this is the perfect worker to take the bill. So this worker has now a strength of 9, and this worker can solve this task. And now we need to use our remaining workers to solve a task of 8. And remember, we don't have any more bills. So here we return false, meaning we can't solve all of these first 4 tasks with these workers. So now right pointer is here, and now right is smaller than left. So we end binary search and we return our result 3. Now the time complexity for this one will be n log n plus m log m plus log n times m. N log n is because we need to sort tasks. M log m is because we need to sort workers. Log n is for the first binary search, and the next log n is because we need to iterate every value from every mid pointer up to 0, and m is because we need to pop the used worker to solve the current task. And space complexity will be big O of n plus m plus m. This n is for sorting tasks, Remember, in Python, sorting requires a space complexity of big O of n. This M is for sorting workers, and this M is for the binary search. And as you can see, this is quite complex. So if you think I'm wrong, please let's talk about this in the comments. I love to learn about this. And now let's go with the code, and hopefully you will get the idea. First, we will start by sorting tasks and workers. So tasks dot sort and workers dot sort. N equals length of tasks and M equals length of workers. And now we'll start our first binary search on the array of tasks. So low equals 0, high equals n minus 1, and while low is smaller or equal to high, the mid pointer will be low plus high minus low divided by 2. And if our formula that we will call solve, which will take an argument mid, meaning if we can solve mid amount of tasks, well, in this case left equals mid plus 1, else high equals mid minus 1. And finally we'll return low, and here we want to create our formula solve. This will take an argument k, and first we want to copy pills and workers, and for every value in the range in between k up to -1 in reverse order, if we don't have any remaining workers, we return false. So if not w, return false. Now if our last worker, meaning our stronger worker, is greater or equal to tasks, we'll use that worker to solve that task. So if w at -1 is greater or equal to tasks at I, w dot pop. Else, here we need to use a pill. So if we don't have any more pills, meaning if p equals 0, we also return false. Now if we have pills, we need to find the perfect candidate for the pill. So candidate equals, and in Python you can do a binary search like this: bisect dot bisect underscore left, and this takes an array, in this case workers, and remember we need to find the difference between tasks at I minus strength. So we are trying to find the perfect worker for a pill. And if candidate equals length of workers, this means we don't have any worker which can take the pill and solve the task. So in this case we also return false. And if we found the perfect worker, we subtract 1 from our pills and we pop the candidate from the workers. And finally we return true. So this is the entire code, and I think it's right. So now let's submit this and see if it works. Here I put a minus instead of an L, so let's fix this and try again. And as you can see, this solution works. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.